It's small, it's boring, it doesn't contain any elements at all. But still, it's not nothing. I'm talking about the empty set. So, first of all, what is this empty set? Well, the empty set is just a set that contains no elements. It's denoted by this symbol here. So, if you think of a set as some kind of box with particular elements inside, as you can see here, the empty set is just an empty box. So a box with nothing inside of it. Doesn't sound too difficult and interesting at all, right? Even though the empty set is nothing more than an empty box. There are some examples where this particular emptiness leads to very definite results. This kind of surprised me at first, because well, it's just an empty set. So let's take a look at the following example. A regular sum looks like this here. So the term on the left describes the following sum: 1 plus 2 plus 3. Normally, the lower number here, k is equal to 1, has to be smaller or equal than the number on the top of the sum, so 3, and 1 is smaller than 3, so everything is okay. Is this not the case, we have an empty sum. So let's take a look at the following example. Here we start from k is equal to 3 and go to k is equal to 1. Clearly 3 is larger than 1, so we have an empty sum. This means that k is inside of the empty set. But what does this mean for the sum? Because the empty set contains no elements at all, we are not able to summarize anything at all. When not summing up anything, we result in 0. So an empty sum results to 0 because we are not summing up anything at all. Now let's take a look at products. So the regular product looks like this here. So the product on the left here describes the following: 1 times 2 times 3. And as for sums, the lower number here, k is equal to 1, has to be smaller or equal than the number here on the top. And clearly 1 is smaller than 3, so everything is okay. Is this not the case, we have an empty product. So let's take a look at the following example. Here we start from k is equal to 1 and go to k is equal to 0. Clearly 1 is larger than 0 and therefore we have an empty product. So k is inside of the empty set. This equals to p to the power of 0, which means there hasn't happened a single multiplication at all. And p to the power of 0 equals 1. This means that empty products result in 1. The empty set is contained in any other set A. Especially that means that it is also contained in itself. Because the empty set is empty, there are no other subsets than the empty set itself. So the set of all subsets of the empty set is the empty set situated in a set. Try to say this really fast a few times. By the way, this power set here is not empty. It contains the empty set. Like an empty box that is contained in another box. When we have the empty set and another set A, there exists a unique function from the empty set to A. This function is called the empty function. If you go through the mathematical definitions of a function, you will see that such a thing here will not make any problems. It is even possible that this set A Here is the empty set 2. So you have an empty function from the empty set to the empty set. By the way, a mapping from a set A to the empty set only works out if A is the empty set 2. The reason is the mathematical definition of a function. Not only mathematicians are interested in the empty set. I read that philosophers also discussed it, trying to find a connection between nothing and the empty set. But the empty set itself is not nothing. It's a set that contains nothing. That's a difference. As I said before, it's like a box that contains nothing. In my opinion, you could also take a look at the empty set from a psychological point of view. Most of the time, emptiness is not a pretty nice thing. Also, the empty set is the loneliest of all sets, because it doesn't contain a single element. I thought about this and have the following suggestion. If you want to, you can write in the comment section which elements you would add to the empty set so it's not empty anymore. You could add your favorite number or any other thing or activity you like. I'm looking forward to your comments. If you liked the video, please consider to subscribe to my channel. I will also make another video with focus on emptiness. The next one will be about empty matrices.